Hello, everyone, and thank you for joining this morning or afternoon, wherever you happen to be in the world. My name is Jennifer Reif, and hopefully you guys all tuned in for the keynote that ended just a little bit ago. We're going to kind of take a little bit more of a technical look at Neo4j, kind of dive into some of the things that really make it a highly valuable technology, what it's all about, and how you can get started with it today. So a little bit of background on me. I'm a developer relations engineer at Neo4j. I love to learn, which is a great thing for this industry, right? And then when I learn something new, I get excited about it and I want to come out and share it with the rest of you. So whether I'm conference speaking, whether I'm blogging about what I've learned, or some sort of other aspect, I enjoy talking about tech. So I'm thrilled to be here today and present this topic with you. I do have some side hobbies as well. I'm missing my kitty cat, so those of you tuning in from home, I hope you're giving your pets extra cuddles for me. But I know we have a very short time period today, but please do feel free to reach out to me. I'm happy to continue the discussion or answer questions at length via email or on Twitter, or however else you're most comfortable with reaching out to me. I'm happy to do that, and here at Neo4j, we are here to help you. So basically, what is a graph? It's basically a set of discrete objects that has some sort of relationships with other objects. So if you tuned into the keynote, you might have heard mention of the 7 bridges cake that was done in our community. And this kind of traces back to Leonard Euler, who was a mathematician in the 1700s. And he designed this problem to try to see if he could get over all 7 bridges in Königsberg and get back to his original point. And so he kind of mapped this out, he drew it out, and tried to figure out, can I actually solve this problem? What he ended up creating was a graph, and what founded the beginnings of graph theory, which is, as we know, graph theory, network science today. But what does this graph theory have to offer? What does graph give us in technology? It really just shows us how our data is connected. So linking things together, showing and giving meaning to the relationships and the value between the connections within our data. Whether you're dealing with relational or document or key value stores or graph, they all do kind of the basic same thing. They're going to store and retrieve data. Relational database, you see an example up here in the left-hand corner of your screen. We're going from just a typical normalized model. We have our employees, and we want to see what departments our employees work for. In this case, we're just picking out one single employee. Her name's Alice. She has an ID tied to her, this 815 number. Now we want to figure out what departments Alice is in. If you're dealing with a regular normalized structure, Alice might work with many different departments. And a single department could have many different employees tied to it. So you've got a many-to-many relationship there. Typically, how you deal with this in the relational world is by using an associative entity or a join table or some sort of lookup table, where you take the ID of the value you start from, you go and find all the places in that join table where that ID appears and grab the links to that, and then go look up the meaningful values of those links in the other table. In this case, we're starting from Alice. We're going to go find the departments that she's tied to in the department members table there. And then we're going to go look up the meaningful values of those departments. So in this case, department names. She's tied to 3 different departments. So that's our relational model. In graph, we're actually breaking this structure apart and going piece to piece directly without that lookup in between. So we're starting from our Alice node, in this case, in the graph, and we have a direct relationship going to the exact 3 departments she actually works with. So you can see there, it's kind of this broken apart, kind of unstructured or less structured set of data. If you compare this, if you're more familiar with document structures or key value stores, this is kind of the translation going from those models. So up in the top there is a key value store. In the upper left, you can see we have a key tied to a value, possibly some other keys. Again, the graph, we're breaking down that structure into individual pieces and then tying and saying, how do these pieces connect with one another? The document store there, again, you see this nested sub-entity type of structure. We're pulling each of those entities out and separating them and saying each of these entities is connected to these others. So graphs allow us to go to a greater depth because of this. You see, there's a lot of databases that handle a variety of sizes and depths very, very well, and they all do these things excellently in their domains, but Graph just kind of gives us an extra level of depth. And what does that really mean? How can it give us this depth? And that's because graphs add context and meanings by giving us this multiple hop sort of structure. So when you start joining and doing a lot of complex relationship entity ties, it gets very complex very quickly in other systems. Where with Graph, we can start from a single entity, a single node, and go out as far down and as many joins or as many relationships across as we like. And it gives us context and meaning for the person. So in this case, we're starting from that person node down in the center, Jennifer, that's me. So you can see I'm tied to a company of Neo4j. I work for that company. I'm friends with another person, Michael in this case, and I like a particular technology, Graph. This automatically gives context and meanings for me as a person. You now know a little bit about me. You might come up and start talking to me about graphs because you know that's something I like and you know I work for Neo4j, so therefore that's a relevant context for me. So there's a variety of use cases that this is used in order to combat and solve some problems and some questions. Several of these come up. There's many, many more than what could possibly fit on this slide. But these are just some of the most common ones that we see. So social network is a very common use case, how people are connected to other people. So you can think of things like Facebook, Twitter, LinkedIn, all types of other social medias, how to connect people with one another. Fraud detection, can I, based on the connections and the relationships in the graph, can I find fraudulent activity or fraudulent people in the network and try to root those out? Network and IT operations, so how are my entities and routers and switches connected in my physical company, line to line? Identity and access management, who has access to what resources and why should they have access to that? And then finally, graph-based search. So based on a search term, based on what I'm looking for, can I find the most relevant, valuable results for what I'm looking for? Here at Neo4j, you'll probably hear this a lot. We kind of like to use graphs are everywhere. And the more you start seeing these structures in the everyday world, they'll start kind of popping out at you. And you'll realize just how commonplace this stuff really is, this network and very integrated and connected type of structure. So one example here is the internet. So these are all the connections of web pages across the world, across all different sites, etc. You can see how tightly interconnected and kind of pretty it actually is when you draw it out. Bank fraud there on the right, so a little bit more sinister of an example. Based on the connections, you might be able to see there that there's a social security number entity that 2 account holders share. You see that 3 account holders share an address. So you can start to pick out, because I can see these relationships and understand the connections, I can start to find things that don't look right or that don't fit normal patterns. So I don't just mean graphs are everywhere in serious situations. There's also some kind of fun, lighthearted, as well as some very sciencey and valuable situations where this is being used. So on the left-hand side, the NASA space satellite. You might not think of this as a typical use case, but it's really valuable to see where are my connections. NASA used Neo4j for their lessons learned. Based on a search term, can I find relevant information that I can use to build more spacecraft or find certain numbers or things we might be able to improve on the next mission? And then on the right there, the Game of Thrones family tree. Got to have a little bit of fun there. So you can start tracking all of the characters and their relationships and families throughout the network. So at its core, Neo4j is a graph database. So kind of pulling that apart and just going to its simplest form, that means Neo4j is a database. So it's going to do lots of typical database types of things. So things like ACID transactions, which make it very, very reliable. This is something that a lot of relational databases already provide. This is something that we at Neo4j thought was very valuable to have. That just means that your data won't get lost in translation. You're never going to have partial transactions committed to your database. Either it all makes it there or it doesn't. And so ACID is atomic, consistent, independent, and durable. And that just means you won't have partial pieces of the graph getting committed and lose your data integrity. And that's really, really valuable, especially when you're dealing with things across a cluster. So whether you're dealing with regions, multiple instances, backups, things like that, high availability types of situations, this is where Neo4j provides these capabilities in order to ensure your system is always up, always running, and there when you need it. We also have a variety of ways where you can connect to Neo4j and build things on top of that. So we have our binary and HTTP protocols that allow you to connect to Neo4j, and our drivers that allow you, using the binary and HTTP protocols, to connect to the database. So you can build all sorts of applications on top of that. There's a variety of programming languages you can use with various drivers. We have things like Java, Python, all sorts of things that are provided not only by Neo4j, but by the wider and broader community as well. So some are built here at Neo4j, others are built by our wonderful community. We thank you for your contributions and giving access to all these programming languages in order to work with our database. So Neo4j is also a graph database. So there's going to be some graph-specific things that it's going to add. There's going to be certain capabilities that, because it's a graph database, it needs to provide that might be different than other sorts of databases. The first off is our graph native engine. This makes transactions really, really fast. We also have a graph storage layer. So we like to say we're graphs all the way down. There's no types of lookup values, matrices, things like that underneath. We actually store the data with index-free adjacency using memory pointers. So again, that helps us make it very fast, but also gives you this very internal native graph type of structure. And that also means we're schema-free or schema-optional, which means that you're very flexible. You can adjust your data model as your business moves and adapts. So we use the property graph model in order to kind of categorize and organize our data in the graph. So the property graph model is made up of nodes and relationships, as we're going to talk about here in just a second. But this is kind of the foundation for how Neo4j stores and retrieves its data. So let's take a look a little bit about how that's done. So the property graph model is known for being whiteboard-friendly. What really does that mean? That just means that it's easy to design and model exactly how your data exists in the real world in the database itself. So let's take just a very simple example. If you were dealing with a new domain, you would probably go to the whiteboard with a colleague. You would draw this up on the whiteboard and start modeling here's our entities, this is how it connects, or how the data flows through the network. And so we're going to take a Lord of the Rings example. I absolutely love these movies, and so this is kind of what's near and dear to my heart. But if we were to take The Return of the King, which is my favorite movie in the trilogy, and look at who are the actors that appear, or excuse me, the characters that appear in that movie. So we have Frodo Baggins, Legolas, and Aragorn that all appear in that movie as characters. Then we have certain actors that will play those particular characters. So again, we see that those entities that are connected with those relationships to now those characters, and you kind of have this kind of flow of data moving through the network. So you draw that up. You might make it a little bit cleaner to present it to colleagues or leadership, et cetera. Business users get all their buy-in. And so you would kind of add a little bit more detail to this. Maybe you'd say, okay, we have our movie. That's going to be our title property. We'll say the year it was released, because that's valuable for our use case. We want to add a label to this, so we want to categorize these nodes just a little bit. We have a particular movie, we have some characters that appear in those movies, and then we have cast members that play those characters. So we're adding kind of these tags and categories to our nodes then. Then when you actually get ready to store the data in Neo4j, it's going to look like this. So you can actually see how very, very similar this looks to what we did at the very beginning on our whiteboard model. It's almost the same. So that's why we say that Neo4j, the property graph model in general, is whiteboard friendly, because it looks very similar to that initial whiteboard model you drew at the beginning. So how do we construct this graph? How do we piece this together? We know what it's supposed to look like now. There's two major components of the property graph data model. That's nodes and then relationships. And then we can add a little bit more detail to what we like to say is hydrate the model with labels and properties. We'll take a look at each one of those components. So nodes represent the objects in the graph. You can categorize nodes using labels. So in our example here on the right-hand side, you can see that we have 4 nodes. We have 2 person nodes, so we're categorizing them or tagging them as being persons. We have 1 company node there in the kind of reddish pinkish all the way on the right. And then we have our technology node in the green on the left. So we're categorizing these nodes into kind of various groups. Then we have our relationships. So we relate our nodes by type and by direction. So you see kind of the arrows pointing from node to node. And we're quantifying or adding context and meaning to these relationships with kind of some text or action type of words. So a person works for a particular company, a person is friends with another person, and a person likes a particular technology. You could choose any relationship type you want. You could name those anything you like, but we want to somehow add meaning and add context to these relationships. Then finally, properties are name-value pairs you can apply to nodes or relationships. So very, very simple. You can put them on nodes or relationships, either one. And again, just kind of adds a little bit more detail, a little bit more meaning to the entities and the relationships we're dealing with. So here we have a person with a name. In this case, we have 2 persons named Jennifer, named Michael. We have a company with a name as well called Neo4j. We have a technology type of graphs. And again, you could give that property value anything you liked, depending on the particular node. And then finally, our last relationship, their person is friends with another person since a particular date. Again, you could give any property type and value you wanted there, name value pair. I've just chosen, I want to qualify how long these 2 people have been friends. So that's the property graph model. Now, what goes along with that, how do we get data in and out of the database? And you're probably going to need some sort of query language to do that. It's what a lot of other databases do. And at Neo4j, we use the Cipher query language. And of course, we have an open source Cipher, so therefore you can extend that and write your own custom procedures and functions and extensions for that as well, and add that on top if you so choose, if Cipher doesn't have the capabilities you need. But let's take a quick look at Cipher. So it's basically SQL for graphs. It combines the power and the standardization of what was available in SQL and basically took that and used it on the graph theory. So we created our Cipher query language in order to use the network and the nodes and relationships that are part of that property graph data model. So Cipher is very functional, it's very visual. It's based on ASCII art, so it does kind of look pretty, but don't be fooled, it's very powerful. It's very declarative, which means that you tell it what you want to retrieve and not how. So you don't have to add all that extra detail and kind of the logic. Cipher knows if you just tell it what you want, it'll determine kind of the best way and how to get to that point. So on the right-hand side there, you see just a very simple graph. A likes B. You can see the ASCII art there underneath it, the Cipher query match, and A node likes the B node. And so if you look at that, we're going to look at the syntax here in just a second. We have a particular example. Jennifer works for Neo4j. What if we wanted to create that in the database? We want to insert that. So we're going to use the create keyword. We have our nodes Jennifer, we have our node Neo4j, and then we have that works for relationship in the middle. So notice that we have 2 nodes, and they're encompassed in parentheses. And if you take those parentheses and you kind of bring them together, they form that circle, which is exactly how we draw the data model in Neo4j. So again, very visual, very easy to read. And you'll see there in the middle that works for relationship. You can kind of see the arrow and the brackets around the works for. Again, it looks very similar to what we've drawn on the data model up above it, making that very easy and visual. So that's how you would insert that into the database, create it in the database. Now, what if we wanted to bring that back? What if we wanted to match that back out and find that we just inserted? You would use I forgot to add the label and the property there. So we have our person label there that quantifies, we have a person node, we have a company type node, and then our properties, which are our name and of course the value that you give it. So we've created it in the database. Now we want to retrieve it back out. And this is the statement that goes along with that. We're going to use a match keyword, so match this particular pattern. that we're going to give it. And we know we have a person type node in there. We know the name is Jennifer. So we want to find Jennifer's node in the database. And then we know there's a works for relationship from Jennifer's node, but we don't know what's on the other side of that. We don't know who she works for. So let's find out. So you'll add the person named Jennifer. We add the works for relationship there, and then you see the parentheses there with kind of that whom in the middle of them. And that's basically just a variable saying we know there's something on the other side, there's a node there, but we just don't know what all is in it. And then we're going to return that variable, and it will return all the values and the details about that node, which of course we know from the visualization above that that's going to be Neo4j. So finally here, there are lots of tools and libraries, and graph visualization tools are a subset of that, that allow you to work with Neo4j, to visualize Neo4j, to do all sorts of the business things that you need to be able to do in everyday or hobby projects or business life. So we'll take a look at some of these, but some of the plugins actually were mentioned this morning in the keynote. So things like APOC, or Awesome Procedures on Cipher. That's a basic standard utility library that has over 500 procedures in it in order to just do various things with Neo4j. We have our graph algorithms plugin that allows you to run things like community detection and pathfinding algorithms, pipe some of that value maybe into machine learning algorithms and things like that to get some of that value over the entire network as a whole. And then things like our GraphQL and GrandStack integration that allows you to pull data using GraphQL and integrate that way. And then, of course, our graph visualization, which there's tons of tools out there, whether you're looking for a vendor product or an open source tool and library that you need to embed or use as standalone. There's lots of things out there for you that can help you understand and explore the graph as you go. So with that, this is the data that we're going to deal with today. We're looking at Lord of the Rings movies, and you're going to see, just even at the simple scale, how really valuable a graph can be and the things that you can learn from it. So with that, I'm going to kind of slide back and transition and do the demo. Okay. So first off, just to make sure everything's working correctly here. There we go. Okay, that should be much better. Hopefully you all can see the data now. So we're dealing with just something pretty simple at this point. So we're looking at movies. And we have characters that appear in those movies, and then we have cast members who play those characters. So there's only 3 types of nodes, 3 entities, and 2 different types of relationships we're dealing with. So again, pretty basic to start with, but we're just really going to see how valuable that actually is. So let's start off with just a simple query. We're going to look at just some movies that are in our database. So match movie, return M. And so we have 13 movies that come back in our database, pretty small at this point. But you can kind of click on each node and kind of open up the properties a little bit. It gives you a description. We've got a review and a review star, so kind of a rating, the release date, and the title of the movie. So there's lots of stuff in here. You can see we've got some documentaries. Oh, I wonder how the Hobbit got in here. That doesn't seem like a Lord of the Rings. Oh, it was actually made in 1977, so this is the older rendition of the Hobbit movie. So the 3 trilogy movies are really the ones that are my favorites. So we already know we can kind of skim out some of this information just a little bit. So let's look at movies where the m.release date, so we're pulling a particular property now, is greater than the date 2001-01. So January 1st of 2000, because I know that, oh, I need to return. So return movie. So I know that the trilogy movies were created after the date of January 1st of 2000. So that gets me down to 9 movies, which is a little bit better. but we're still pulling some things that really aren't related to the trilogy. So we've got looking at the Lord of the Rings Symphony. So this is a documentary. We've got a Passage to Middle-earth. That's also a documentary. So this is information that's really not valid in what I'm after. And I could even go after this a little bit more. I could return just the title and return the release date. And I could even order by the m.release date in descending order. And so I could pull it in more of a tabular format, which is a little bit sometimes easier to read the titles if you're looking at a lot of nodes. But still, this is more information than what I need. So let's kind of switch this up just a little bit. And we'll just look for a particular movie. Let's look for the network around a particular movie. So my favorite is the Lord of the Rings, the Return of the King. And I'm going to go ahead and copy this title because I'm going to end up using it here in just a bit, and it's a really long title to have to type. So we're going to return everything about that movie. So we're just going to return M. And there's our one single movie. Now that's not really super valuable at this point, so let's actually pull a relationship. And we know we have characters that appear in those movies. So let's look at characters, and then we're going to return all pieces of this. So the relationship, the movie, the relationship, and the character. Okay, that's a little bit better. So even at this level, we see all the characters that, if you're familiar with this series, that are very near and dear to everyone's heart. So Frodo, we have Faramir in there. We have orcs, maybe not so near and dear to people's hearts, but still kind of interesting. So even at this level, even one relationship, you could start looking at, okay, Peter Jackson, who's the director of these movies, maybe he has an unusually high number of characters involved in his movies. Or maybe this movie is the only one that he has a really massive character list. Or maybe it's rather small for his scale, or in the general of movies in general. So you can even start comparing and looking at just at this level across different movies, across Peter Jackson's movies, etc., and kind of see where this fits in the scale. But we know if we go one more level out, there's actually some more value to be had here. So we have cast members who play particular characters. So let's go out and look at those now. So add those on. And then we also need to retrieve those components in our Cipher query. So now we have this kind of double ring where we have our movie in the center. We have characters that are appear in that movie, and then we have cast members who play those characters. Now you can already, your eye is kind of automatically drawn to just certain things. So first of all, we have several people here who play this character. There's another kind of group clump down in here. We even have some over here. So automatically that might start drawing your attention, and you might want to dive more into that. But let's kind of take a look across all three movies, because I think this is where it really gets interesting. So we're going to pull out this, and I'm actually going to add in a clause for all three of my movies. So and this is where that copy paste is going to come in really handy. Fellowship of the Ring, like that. And then we're going to do the Two Towers. These movies and books all have super long titles, so it's very hard to type all of this. And then we're going to say all three of those movies. Imagine if you had a list of 50 movies or 100 movies you wanted to search on. Putting it all at the beginning like this, almost as a parameter to be passed in, is kind of really helpful to kind of clean up your query. So we're going to look in this list of movies. We're going to look for where characters appear in those movies and the cast members who played those characters, where the m.title is in that list of movies that I'm passing into it. And so this is going to pull back a decent amount of data, probably far too much for our eyes to really kind of take in at this point. But you can kind of see some overlap happening between all three movies. You've got some characters and some cast members that are kind of all grouped together in there with all three of these movies. And you kind of got some outlying things. You can see some connections across, and that might kind of be interesting to look at. So let's dive a little bit deeper into that. So where the titles in movies, and where I'm going to draft this up really quickly, and I'll explain it here in just a second. where cast members play characters and where the size of that is greater than 1. So basically what I'm saying is I'm looking for this particular pattern, a cast member played character, and say where that cast member played more than one character, so multiple characters. And this will return a little bit of a smaller graph, something that's a little bit more consumable for our eyes. And I'm going to kind of organize this in the movies in chronological order here, just so it's easier for me to kind of pull apart. I like organization and things, so we're going to kind of do that a little bit so we can kind of move through the series here. So already we can kind of pull some things out that are kind of interesting. First off, you'll see Billy Jackson, Katie Jackson characters over here. They have parts in all 3 movies. So there's one character here, there's a general character there, and then kind of a general character here. So the Katie and Billy Jackson, those are Peter Jackson's kids. So this is kind of a family affair. He's looped them into this. Now, whether he just didn't want to go out and have casting calls, or they happen to be on set, or what have you, it's just kind of interesting to see. Okay, he's actually kind of looped in some of his own family members, and he actually appears in these movies as well. I'll see if I come across his node, but really the one that's interesting here is Craig Parker. Now, I was a huge fan of this series as a kid. I knew a lot about the internals, behind the scenes, etc. And Craig Parker plays the character Haldir in both the first and the second movie. However, Haldir dies at the very end of the second movie and doesn't appear at all in the third movie. But you notice that there's this relationship from Craig Parker down here, and guess what? This character appears in that third movie. So even after his character is done and over at the end of the second movie, Peter Jackson brings him back for the third one. Why is that? Why would someone who's really no longer relevant to the set and to the series and the storyline be brought back for that final movie? So this starts to get the wheels turning of maybe he just needed work, or maybe he wanted to keep an intimate cast and try to keep those who had worked on the beginning movies. Maybe he wanted to keep them throughout the entire series and say everybody played a part in this till the very end. Who knows? But it does start kind of asking some interesting questions about how this kind of relates. So we'll go ahead and run one more query here. And basically reversing this a little bit. So we want to look at characters who have more than one cast member attached to them. So you're not going to get central characters in this. You're not going to have where you have a particular character that you're just going to substitute actors willy-nilly. If you did that with your lead characters, people would be very, very upset. So these are going to kind of be one-off, kind of sideline characters almost. That aren't quite as popular, that people aren't going to know as much about, but there's still some really interesting details here in this data. So categorize these really quickly in chronological order, just to move through the data. Now, what's really interesting, what I find the most interesting about this, again, I knew a ton about this movie series, but you'll see, but you'll see that down here, we have this cast member, Howard Shore, who's connected with this Rohan soldier in the final movie. Howard Shore is actually the film composer. So he wrote the music score for these movies. Why in the world would you have the film composer appear on set, go through the hassle of makeup and costuming and probably, a few kind of acting tidbits before they go on camera? And why would you put them through that when you have casting calls or people who do this all the time? And so it starts begging the question then, if he's pulled in the film composer for this movie, has he done this anywhere else? Has he done this for any of his other movies? What about maybe your costume designers or your makeup artists or your set designers or set builders? How many other people has he tried to include and put them on screen and kind of forever add them to the list of on-screen individuals? So even some of the things that, even if you're really familiar with the data set, there might be some things when you put this into a graph, you can find these hidden relationships and understand more about the data than what you can see on the surface. So with that, we're going to kind of go back to our slides and just kind of wrap up with a couple more resources here. So first off, please do feel free. You can interact with Neo4j. You can get access to Neo4j today with our Neo4j download. That is a local application download, as well as our Neo4j sandbox. So if you're running in an environment where you can't download something, download an application, by all means, we have cloud instances that run Neo4j sandbox where you can interact and run, pull in data or use some of our default data sets there. Our developer guides give a lot of background, how to get started with Neo4j, what it does, kind of the internals, as well as the Cipher query language. So if you want to know more information there or want to kind of get up to speed on the query language, by all means, try that out there. Data import, so trying to figure out how to get data in and out of Neo4j. That's kind of a really important topic for those who work with databases or deal with databases. So feel free to check those resources out. There's lots of options there for you with different types of data and different types of import. We also do have a certification out there that is free and online and available to anyone who would like to take that. You can access some of the resources. It'll try to get you prepped for what you need to kind of study and review and know before you dive into the certification. But please do feel free to do that. You'll get a really cool sticker and t-shirt once you pass there. And again, please do feel free to reach out to me, Twitter, email, however you're most comfortable. I'm happy to continue and answer questions there. But now we're going to open it up for Q&A, and we are also going to display the Hunger Games questions. So for those of you who are in on the Hunger Games kind of interactive side trivia game, feel free to take a look at these questions and answer those there.
Awesome. Thank you, Jennifer. Right now, I'm going to show you some of the questions. We actually got quite a few questions here today. And one of the questions was actually about how do I get a t-shirt, which you answered a little bit by getting Neo4j certified. You can get a t-shirt from Neo4j. We'll send you a t-shirt and a laptop sticker. But then maybe you can take some of these other questions here.
Sure, absolutely. So the first one here is asking about a good way to think about choosing something like a property or label versus node and relationship. It really just kind of depends on your use case. I know everybody loves that term. Well, it depends. But it honestly, you need to look at what are you trying to get out of your data? What kinds of questions are you trying to solve? Am I needing to understand particular values? Am I searching for something? In that case, maybe a property might not be the best fit if you're searching within a string or searching for lists of values. Whereas if you're trying to traverse and find a path of something, like I want to understand kind of the relationships that exist between these two distant entities, then something more like that node and relationship type of hop is something that Neo4j does very well, showing you kind of that traversal and path and what exists between the two. So looking at GraphDB for master data management, that was another question on here. Absolutely. So there's lots of use cases, white papers, documentation, etc. for this very thing. Where a lot of people will use Neo4j graph databases in general for master data management. I think I did mention towards the beginning that you can use it to determine your resource and identity and access management. And so Neo4j does very well at understanding what are my connected entities, what do they relate to, what do they combine into, do they have access and why, etc. So.
And maybe we have time for one more, so choose wisely.
Sure. Okay. So looking particularly at Cipher, is the create statement creating the relationship or the two nodes and the relationship? So that is an excellent question. So the create statement will create whatever you specify in the pattern. So therefore, if you specify a node, it will create a node. If you specify nodes connected with a relationship, it will create the entire pattern, so both nodes and the relationship. And it does that kind of without checking for duplicates. So there's kind of another clause or a keyword that's used called merge. that actually handles unique values in there. And so if you want to avoid creating possible duplicates, then merge would be the way to go on that. But yes, create does insert the entire pattern that you specify. So whether that's individual nodes or relationships or an entire string of a path, it will absolutely create that and insert that whole thing for you.
Well, thank you very much, Jennifer, for joining today. Hopefully everyone got a chance to do their Hunger Games questions. And now we're going to end this so you can join some other sessions. I believe we have some coming up in just a few minutes at 4:45. We have graph visualization, neo-semantics, building spatial search algorithms, and software applications are graphs, in addition to a couple of great lightning talks. So thank you, Jennifer. Enjoy, everyone, the rest of the day here.
Thanks.